In a sport where milliseconds can decide the difference between first and second, you'd think the winner is decided by whoever brakes later, or accelerates earlier, or has the bravest driver. But in modern Formula One, the winning move might happen before the lights even go out, because the fastest thing in F1 might not be the car, it might be the decisions, computed, simulated, filtered, and fed back to humans at racing speed. Formula One has always been a proving ground for cutting-edge technology, but by 2026 it's more true than ever, not just because the cars look different, but because the entire sport is shifting into a new era of optimization.
We continuously embrace change. We need to improve safety. That is a continuous process. We need to follow societal trends for technology, which is what we're trying to do. And we need to make racing always more exciting. And all of these things make it necessary to change regulations on a periodic basis. This is why we're changing regulations for 2026.
That clip sounds like a mission statement, but there's a hidden message in it. F1 isn't just changing the car, it's changing the game. Because when the rules shift, teams don't just build a faster car, they build a faster way of finding speed. And the truth is, in modern Formula One, the performance gaps are so tiny that the race starts long before Sunday. It starts in factories, in simulators, in data. And this isn't change for the sake of change. The FIA are obsessed with one thing, making the racing closer.
A significant part of these regulations is always thinking about the fan and the people who watch motorsport. We believe we made a step towards closer racing in 2022. There's also things we got wrong. We are trying to get it completely right now. We believe the racing will be much more exciting and much closer between cars.
That's the promise. Closer racing, more action, more spectacle. But what's interesting is how they're trying to achieve it. Because they're not just adding a new feature, they're resetting the whole system. So here's the question. How do teams find performance when there's almost nothing left to find? And the answer is, they don't chase one massive breakthrough, they chase 1,000 microscopic ones. Across data, simulation, aerodynamics, energy deployment, driver preparation, and in 2026 the rules force all of those pieces to work together even more than before. The FIA calls it a nimble car.
The cars will have quite a visual difference to current cars. They will be a bit smaller in dimensions. We're trying to make what we call a nimble car. This is cars that are small in all dimensions, also a bit lighter. They will have some visual cues. The front wings, the tires will be different, the rear wings.
Smaller, lighter, different. Sounds great. Until the FIA adds this.
We expect cars to be still very challenging to drive for the drivers. There will be a bit less downforce on the cars. There will be a few more things to look after for the drivers.
That last line is huge, because 2026 doesn't just change the car, it changes what the driver has to manage. Less downforce means the car moves around more, slides more, lives closer to the edge, and at the exact same time, 2026 adds more systems that can be controlled, adjusted, optimized. So driving fast is still the job, but managing the car becomes even more of it. And to understand why this is happening, we need to talk about what an F1 car has quietly become behind the scenes. Modern F1 cars aren't just fast, they're instrumented. They're monitored like a high-performance aircraft. And the best way to understand that is to hear what the people inside the team say it feels like.
So every bit of information in our data stream represents a temperature, a pressure, a speed, a torque that's being monitored really closely by someone as nerdy as me sitting back in the factory.
That's modern Formula One. Not just driver versus driver, but an entire system watching the car's health and performance in real time. And it's not just one sensor or two, it's everything.
Well, we generate data from a variety of sources. Primarily, it's from sensors on the car itself. And those can be anything from measurements of physical quantities like temperatures, pressures, torques, speeds, right through to things like the operation of the system, so the internal state of all sorts of things on the car, like the gearbox.
So it's not just how fast are we going, it's how healthy is the car? How close to failure are we? How much performance is hidden inside this thing, if we dare to use it? And the way the car is wired makes it feel less like a vehicle and more like a network.
And those sensors are physically connected either through an analog system to the ECU on the car, the electronic control unit that runs the whole car, or through a series of network buses that we call CAN buses around the car that bring information back to that central unit.
So sensors everywhere, feeding a central brain. And then the car fires all of that back to the team, which leads to the obvious question, How much information are we actually talking about?
Well, if we take the total amount of data generated over the weekend by the car, including video and all sorts of ancillary information, it's probably close to a terabyte or even a bit more per car. But if you look at the really exciting bits of data, which are the live data generated by the car while it's running, we're looking at about 30 megabytes a lap of live data, and 2 or 3 times more of that once the car is in the pits and we offload it.
That's insane. A terabyte per weekend per car. And the important bit isn't even the total, it's the live portion, because the live portion changes decisions. It's the difference between reacting late and reacting early enough to win. And Mercedes put a number on the scale of the sensor network too.
There are over 250 sensors on the car during an average race weekend, and these can be divided into 3 main categories: control, instrumentation, and monitoring, all of which deliver pressure, temperature, inertial, and displacement data. These sensors are embedded into all systems on the car, and their size varies according to their function and type. For example, there is the FIA mandated TPMS system, which measures tyre pressures, and these are installed inside the wheels. In addition to this, we have small thermal imaging sensors mounted on the wings and floors to measure the surface temperature and degradation of the front and rear tyres, respectively.
So when teams say they're watching tyre wear, they're not guessing, they're measuring it like a scan. And they're doing it while the car is being pushed at the absolute limit. Now, the reason this matters isn't just, wow, that's a lot of data. It's that in Formula 1, you don't get unlimited attempts. If you make a mistake during testing, you don't just go again.
Track time in F1 is a very limited resource. We're not able to go back out and repeat a test if something goes wrong, so the pressure is really on to get it right the first time. And this applies to the time we spend on track, the time we spend in the wind tunnel, and even the simulations that we do.
That's the tension. It's not a lab, it's a race weekend. Everything has a deadline. So the job isn't just collecting data, it's collecting the right data. Because most of the numbers don't matter until one of them matters more than anything else. And once you've got that much information, the next question is obvious. How do you move it fast enough to matter?
So once we've gathered up the data on the car, everything is synchronized so we know exactly what's happening at a precise time on each one of those sensors, and the data is then encrypted and transmitted back to the pits through our telemetry system.
Encrypted is doing a lot of work in that sentence, because this isn't just engineering, it's advantage. And what I love about this next part is it shows something you almost never see in Formula 1, cross-team cooperation.
Now, the telemetry system is a common system across all the F1 teams, so there's quite a big infrastructure set up around the racetrack to make sure that we get pretty much 100% coverage, even at some pretty difficult racetracks like Monaco, where we're going through tunnels, or Baku, where there's a lot of reflections off some historic buildings.
10 teams hiding everything, and yet they all rely on the same invisible network to keep the sport alive. Because if that link drops, you're suddenly blind. And Mercedes explain why it ended up like this.
We used to set up our own masts, our own radios, our own telemetry systems, and we decided in the end that that wasn't the competition that we were really in. We want to be racing each other on track.
That line says everything. The fight is meant to be car versus car, not antenna versus antenna. And even then, it isn't the same everywhere. Distance still matters.
Your live data, such as on-car telemetry or voice or video calls, in a European event, those are within 10 to 15 milliseconds, so well under a second and almost instantaneous. As we move into the flyaway events, that can range depending on the actual distance from the circuit. So somewhere like Australia or Japan, we're looking at 300 to 400 milliseconds.
That sounds tiny, but at racing speed, that delay is a long distance. So even in the age of real-time analytics, physics still gets a vote. And none of this is just for engineers. Drivers obsess over it too. Not because they love spreadsheets, but because it tells them the truth.
During a practice or a qualifying session, the drivers are very keen to see how their performance is comparing to their teammate. In particular, am I braking later? Am I carrying too much speed? Not enough speed? Is he turning in earlier than me? Where's he gaining that time?
That's the real fight. Because your teammate is the cleanest benchmark you'll ever get. Same car, same track, same day. So when someone finds 2/10, it usually isn't magic. It's one corner, one brake release, one tiny detail that adds up. And Mercedes even point out how standardized this has become.
The vast majority of other Formula 1 teams use a bit of software called Atlas, made by a company called McLaren Applied.
So modern F1 isn't just about driving a fast car, it's about understanding why it's fast. And that's where the sport starts to feel like something else entirely. Because once you can measure this much, the next step is obvious. You stop analysing the race and you start predicting it. Now layer the 2026 regulations on top of everything we've just described, because the FIA isn't only changing the car's shape, they're changing how it behaves, how it overtakes, how it manages energy, and how it moves through the air. And the biggest shift is active aerodynamics.
Well, one of the main changes for 2026 aerodynamically is that the bulk of the drag of the car, the aerodynamic drag, comes from the rear wing. So in order to reduce the overall drag, we have an active element on the rear wing. We have more moving elements, and they move to a greater degree. And as soon as you have a rear wing that moves, from our simulation work with the teams and with drivers, it was pretty clear that you needed to have an active front wing to match the balance characteristics. There's certain conditions where the drivers didn't feel comfortable with a car which had an enormously forward aero balance, so lots of downforce on the front and not much downforce on the rear. So that led us towards the need to having an active front wing as well as an active rear wing.
So it's not just move a wing, it's make the whole car behave properly while it changes shape. And then comes the line that basically ends an era.
The DRS in itself on the rear wing will not be used to allow or facilitate overtaking anymore. It will be used by default on every straight line by every car.
So what does replace it? Instead of one button that only matters when you're within a second, the car becomes something with multiple operating modes.
This is not DRS. This is what it looks like in the FIA renders. The upper two elements of the rear wing will open at certain sections of the track, as will the upper two elements of the front wing at certain elements of those track. And this is what the FIA are calling both X mode and Z mode. X mode is where the car is running in a low drag configuration, trimmed out to not just for fuel economy, but for top speed. It'll help cars follow each other down the straight. The drivers will be in charge of activating this X mode. Then when you go into Z mode, it is a high downforce configuration as you get into corners. Now that will be activated from the X mode as soon as the driver deactivates it manually or the driver touches the brake, very similar to the current DRS arrangement.
So the car now has two aerodynamic personalities, one for straights, one for corners, and just switching between those modes becomes part of driving fast. But that's only half the change, because overtaking doesn't disappear. It becomes an energy problem. The FIA still wants overtaking, they just want it to work differently.
To help the overtaking, since now both cars will have rear wing open and front wing flap open, we are going to allow to the car behind to deploy more ERS, so electrical energy, for a given portion of time. I am given an extra amount of energy for that one lap, which I can deploy the way I want.
That's a completely different type of racing. Instead of open wing and slingshot past, it becomes you earned extra energy, now use it perfectly, which makes overtakes more tactical, more driver controlled, and it ties directly into why the FIA keeps repeating one phrase, road relevance.
It is our objective to keep Formula One an area of innovation. It is very important for us, as well as a sport, to make sure that Formula One is an area of innovation and of what we call road relevance. The new power unit regulations, for example, they increase electrification, which is a reflection of what's happening in society. They're going towards sustainable fuels, which is what has to happen in society at a much faster rate over the next decades.
So now, performance isn't just grip and tyres, it's energy budgets, harvesting under braking, deploying on exit, deciding when you can spend power and when you need to save it. And once you combine active aero plus energy management plus tyre behaviour, the number of possible races inside one race explodes, which is why teams lean harder than ever into simulation. Because humans can't brute force every scenario live, but computers can. And if you can compress chaos into a decision faster than everyone else, you win. And through all of this, the FIA keeps pointing at the same target: cars that can follow. Because if you can't follow through corners, you can't attack.
To be able to overtake, you need to be close to the car ahead of you. And if you can't follow in a corner because it's generating so much dirty air that your car gets unstable and you need to pull away, then the moment you are on the straight line, you need to recover all that loss.
That's the sport. So 2026 is trying to reset the baseline. Less dirty air, more following, more battling, and still a driver's championship. And here's the sneaky part. the 2026 concept car isn't really the car we'll end up with. Because teams develop, they interpret, they find clever solutions, they make it fast in ways nobody expected.
Will the new cars in 2026 look anything like this model? Well, the answer is actually probably not.
Because that's Formula One. The real car isn't the render, it's what happens after thousands of iterations, where everyone tries to solve the new puzzle first. So yes, milliseconds decide first and second. But those milliseconds aren't only found on track, they're found in airflow you can't see, in energy you can't waste, and in decisions you never hear. And in 2026, more than ever, pole position might be earned as much in the data center as it is in the cockpit. Because in Formula One, innovation is speed,